So it's going to speak not about a new class of vulnerability, but let's say about a new way to new analysis technique. And maybe some bugs that were overlooked in the lab. Can we say that? Yes. Okay. So it's not going to. Well, I don't want to spoil it. So please go ahead. And if Paul shows up, we'll put his talk at the end of your presentation. So basically, you have till actually you're quite on the time that we're scheduled for your talk, maybe 15 minutes advance. Thank you, Julien. Thank you very much.
Hi everyone, my name is Julien Malek. I'm French. I work for Microsoft. I work in the Microsoft Security Engineering Center. So you heard of MSRC before, I believe. Microsoft Security Response Center, who are the people handling the bugs that come from external researchers. I work for MSEC, which is Microsoft Security Engineering Center. So we discover the bugs before the projects are released. And we patch them actually before the public finds them off the system. So today my talk is about a specific code pattern that is allowed by the C standard. Those are zero allocations. So basically, when you do malloc, I believe most of you guys program in C or Unix at least. Who does Unix programming? Who does C programming? Who doesn't do any C programming? So today I'm going to talk about zero allocations. Basically, when you do malloc 0, it's defined, as far as I know, by the C standard, POSIX C standard. So it's an allowed code pattern. So when you do malloc 0, it actually returns a valid pointer. It doesn't return null, as you would maybe expect. So usually when you have a malloc 0, it's not an intended behavior. So it means that if we find all malloc 0 that happen in some software, we have a good chance to find new vulnerabilities. We have developed with Shubhendu Hari, who is Microsoft research guy who does lots of skill improving and stuff like that. So we've done an analyzer that finds all such vulnerabilities in the Windows kernel. So I'm going to talk briefly about what is the zero allocation, how we find some introduction to automated techniques. So I'm going to talk about quickly data analysis, model checking, zero improving, difference between those techniques. And if you have any questions, please interrupt me at any time. You can just ask in English or in French if you wish. It's not a problem. So let's just get started. So first, I'm going to give you a couple of scenarios where zero allocation happens. So if you have like a size variable, you read from a trusted source, you malloc that size. Obviously, you do a check to null because if malloc returns null, then it's because something bad happened, so you're supposed to check that. So you check that, and then you copy memory of size -1. When you do that, normally you should not have any vulnerability. The fact is, if size was 0, doing size -1 will trigger an integer underflow. So basically, you do memcopy of a very big size on a pointer that was 0 allocated. So you trigger a buffer overflow, which is a very specific kind of buffer overflow. But this is very bad because you can have code execution. So we have to detect all such patterns, and not just how pattern that looks like exactly that example, but all those patterns where the size can be 0. We need to know where that happened because this is usually unintended. Scenario 2, still you read the size from a trusted source, you multiply by, say, size over type. Just a second. Right on it. Scenario 2, you multiply by the size of a type, and still you assume that something was allocated, and then you just dereference the pointer. So basically here, you do a check for upper bound, so if it was too big, you will actually return an error. If not, then you just multiply by a certain size, and you allocate that, and then you assume that at least one entry was allocated. So here the reference here on this particular location is invalid because this is a 0 located. So if that number which is untrusted was 0, then the whole size obviously multiplying by 0 gives 0. And so you allocate 0 bytes, which actually allocates like some bytes, not 0, but some bytes. And then you have an invalid reference because if field was like at an offset in a structure that is big enough, then you're going to write into invalid memory or like trigger a heap overflow. So this is the kind of vulnerability we're going to talk about today. For example, still you read the size from an untrusted source, you add something, say the size of the type, and then you copy the size of this type, but the thing is you can have an integer overflow. So because the integer is on 32 bits, so its maximum value is like FF, or like 4 billions, and etc. So the fact that you add 1 or you add even like one at a constant size, make it to wrap, and this gives the allocation 0 or a small allocation